A bank puts their data on Amazon Cloud, and that's stored in Virginia somewhere, although the bank is a Japanese bank located here. If they apply this self-sovereign access control, you really don't care where the data exists. And if it's under US data sovereignty law, no one can access the data because you control the keys, right? And this is what we're giving. We're giving organizations agency over access control to the keys regardless of where the data resides. So I want to continue on to the next class of problem that is very important to solve in business, and that's workflows and contracts. Okay, so with this class of problems, the question that we have is, how do we enable global business workflows to operate securely? Global means you have one office in Japan, you have another office in Singapore, Myanmar. How does a contract, digitally signed contract, get recognized in Myanmar, for example, as legally binding contract? These types of questions. Okay, so let's understand where we are now with the current system. The problem here is that with international business, it's being restricted for a number of structural problems with how we deal with digital signatures and digital data. The first problem is that, believe it or not, the legal basis of digital signatures is geopolitically aligned. So just to explain to you, if two companies sign a digital contract here in Japan using Japan's certificate authorities, it has a legal basis for being a legally binding contract here in Japan. However, if the contract is signed in Korea with a Korean certificate authority, that does not have legal basis for being legally binding here in Japan because the certificate authority is not recognized by the Japanese government. So this is the property of the certificate authority system being it's not so much, it's not centralized, but it's a very politically aligned system, and there's no crossover. And in fact, they're trying to fix this problem by doing federation of companies, but it's just a broken system. Number two, data sovereignty has the same problem. So, data sovereignty. Data sovereignty means which jurisdiction is under, which country controls the rules for access of data. So you guys might recall a few years ago the safe haven regulations for, as GDPR was coming into recognition, safe haven for United States was repealed due to the Snowden leaks. I think it was the Snowden leaks that precipitated that. What this means is that if a European country had saved its data on Amazon servers clouds and that server existed in the United States, previously it was under the sovereignty of Europe, and there was a recognition between the two regions of rules that govern the access and ownership of that data, and that's since been repealed. So as we go to the cloud, the question is, under which jurisdiction are the laws that control that data? And that's not very clear now. Particularly as cloud networks get hacked, the question becomes much more important. And finally, there's no finality with transaction state. And here with this, I mean that within trade finance, for example, as shipments go through the ports, you want to record the state of the shipment and therefore maybe trigger some part of the contract payments or something. What's the finality of the data that gets recorded? There's no finality because, again, digital signatures are not recognized across borders. So this is what's hindering international business. So if you go back to the MBA architecture, data provenance, right? Digital identity, data provenance, workflows. This is what we get out of it for this type class of problems. Number one, we are assuming that governments are able to accept blockchain-based digital signatures. We do get a global signature infrastructure which will allow us to recognize the legality of digital signatures on contracts across geopolitical lines. The second is data sovereignty. So if you can use the blockchain, again, we define a cryptographic identity. In our case, we use the blockchain as a public key infrastructure. With that infrastructure, you can not only digitally sign data, but you can encrypt it so that only the people you want to have access to the data can access the data, regardless of where the data resides. So what we get out of here is that, let's go back to the case of a bank. A bank puts their data on Amazon Cloud, and that's stored in Virginia somewhere, although the bank is a Japanese bank located here. If they apply this self-sovereign access control, you really don't care where the data exists. And if it's under US data sovereignty law, no one can access the data because you control the keys, right? And this is what we're giving. We're giving organizations agency over access control to the keys regardless of where the data resides. Okay, and then finally, state finality. This is actually a well-known property of how people are trying to use blockchain. R3's Corda, I think is their chief scientist, Richard Gendel Brown, puts it very well, and I love this phrase, and so much I loved it, I stole it from him. He says, what you see is what I see. So as your applications go through different states, all right? Let's say a shipment arrives in the port, and an IoT device records the fact that the shipment has arrived, it records the ID of the shipment. That data needs to be transmitted to the stakeholders of that particular shipment or that transaction. And with this finality, you can get not only a record of the data, but a record that everyone else who's involved also received the record of that data, and proof that they know that you received the record of the data. So everyone knows that data has received the data, and everyone knows that everyone else knows that they've received the data.